If you pour cold water in a glass, the water will cool the surface of the glass, which in turn cools the air near the glass. When the temperature of this air reaches the dew point, the water vapor in the air condensates and forms small water droplets on the glass. Hi, my name is Magnar Nordahl. I'm an airline captain and instructor. Today, I will talk about something many pilots are not conscious about when they read the weather reports. A meteorological aerodrome report, or METAR, is a routine weather report issued for a specific airport. METAR is also known as a meteorological terminal air report or a meteorological terminal routine weather report. At most airports, the METAR is issued every half an hour, and it can also be issued every hour. The METAR contains weather data observed for the last 10 minutes before the METAR was issued. The METAR is written in code, which is known by the pilots. Here is one example. And this is the International METAR code format as defined by the World Meteorological Organization. In North America, the code is slightly different. The METAR is for Bangkok Suvarnabhumi Airport in Thailand. The date is the 7th of the month. The time is 0230 UTC, which is 0930 local time. The wind is from 070 degrees with a velocity of 6 knots. The wind direction is variable between 040 and 100 degrees. Visibility more than 10 kilometers. Few clouds at 2000 feet, scattered clouds at 10,000 feet. Temperature 31 degrees Celsius, dew point 23 degrees Celsius, sea level air pressure 1009 hectopascal. No significant change expected for the next 2 hours. What I want to focus on in this video is the dew point. It is often overlooked, but it can give valuable information for the pilots. The dew point is defined as the temperature the air must be cooled to become saturated with water vapor, assuming the air pressure and water content are constant. When cooled below the dew point, water vapor will condense and form liquid water droplets. Here is an example. If you pour cold water in a glass, the water will cool the surface of the glass, which in turn cools the air near the glass. When the temperature of this air reaches the dew point, the water vapor in the air condensates and forms small water droplets on the glass. Therefore, the dew point will tell you a lot about when fog and clouds will form. Or to be more specific, it is the difference between the temperature and the dew point that is of interest. This difference is called dew point depression, or just spread. The smaller the spread, the higher is the relative humidity. With zero spread, when the temperature and the dew point are the same, the relative humidity is 100%, and water drops will form, creating fog or clouds. Fog is just a cloud touching the ground. When the spread is 10 degrees, the relative humidity is 50%. That is an easy rule to remember. In this METAR, the spread is 8 degrees, and with this temperature, the relative humidity is 63%. As a rule of thumb, the cloud ceiling will be 400 feet multiplied with the spread. This rule is valid when you're talking about convective clouds or cumulus clouds. When we look at the METAR for Bangkok Airport, we notice that there are few clouds at 2000 feet. When we use the rule of thumb, clouds will, in perfect conditions, form at 400 feet multiplied with 8, which is 3200 feet. This is higher than reported, and there might be several reasons for that. First of all, to measure the accurate height of a cloud, you need a ceilometer. This instrument uses a laser beam pointing straight up, and therefore it can only measure the height of a cloud straight above. But when there are few clouds, the ceilometer might not register any clouds at all, and it's up to the observer to make an estimate. Very often, the observer will be on the conservative side and select a lower height than it actually is. That's not a big matter in good weather conditions. But I have flown to airports where the cloud base was reported to be 1,000 feet regardless of the actual weather. The ceiling could be 200 feet or 4,000 feet, but they always reported 1,000 feet ceiling. Experiencing this, I started to use the rule of thumb. If the spread was 1 degree, I expected to fly in ILS approach to minima, 200 feet. When the spread was 5 degrees, I expected the cloud base to be at 2,000 feet. And that worked very well. But there are always exemptions to rules. There are some factors that can make the rule of thumb not so accurate. One factor is that the distribution of temperature and dew point with the increasing altitude is not always linear. In this example, the temperature and dew point are very close to each other up to about 2,000 meters. And that area is very moist. Higher up, the air is very dry. Secondly, temperature and dew point are given in whole degrees Celsius. When the temperature is shown as 31 degrees, it can be anything from 30.5 to 31.4. And the same applies for the dew point. Therefore, the given temperature spread might be more than 1 degree from the actual spread. For example, in this METAR, the spread is 0, and we should expect fog, but the visibility is 4,900 meters, and the cloud base is 400 feet. The temperature might have been 10.4 degrees, and the dew point 9.5 degrees. A third factor is precipitation. This METAR shows light rain and a temperature spread of 2 degrees. Still, the clouds are higher than expected by the rule of thumb. The reason is that the air is humid over wet ground. And finally, the ceilometer has limitations as well. It will register the cloud base to be 100 or 200 feet higher than it really is. The reason is that the clouds are fluffy, and the ceilometer must register a certain amount of water droplets to define a cloud base. When flying inside the lower part of a cloud, you will have zero visibility ahead of you, but you can see the ground below. Therefore, you should be prepared for fog when the temperature spread is 2 degrees or less.
Minimum 200. 100, 50, 40, 30, 20, 10.
Okay, that's all for this time. If you like this video, please share with your friends and all that. Thank you for watching. Have a wonderful day and happy landing.